Hello students, welcome to this lecture, one pair of linear equations. So in this lecture, we will discuss ncert exemplars problem. Okay, so in this lecture, basically we will discuss very short answer type questions from ncert exemplar, one pair of linear equations. So let us see question number 1. So in question number 1, here we have, do the following pair of linear equations have no solution? Okay, so we have to justify our answer. So we have given this pair of linear equation and we have asked, do the following pair of linear equations have no solutions? Okay, so let us solve it. How to solve it? So we know for condition for no solution, that is a1 by a2, this is equal to b1 by b2, but does not equal to c1 by c2. Okay, so for first one, here we have given pair of linear equation 2x plus 4y is equal to 3 and 12y plus 6x is equal to 6. Okay, so in first pair of linear equations, here we have given these two linear equations. So if we now compare this pair of linear equation with the general form of pair of linear equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, then here you will get the value of a1 is equal to 2, b1 is equal to 4 and c1 is equal to minus 3. Okay, and a2 is equal to 6, b2 is equal to b2 is equal to 12 and c2 is equal to minus 6. Now, if we find the ratios a1 by a2, b1 by b2 and c1 by c2. So here you will get a1 by a2, this is equal to 2 by 6 and that is equal to 1 by 3, and b1 by b2, this is equal to 4 by 12 and this is equal to 1 by 3. Okay, and c1 by c2, this is equal to minus 3 by minus 6 and this is equal to 1 by 2. Okay, so here you can easily see a1 by a2, this is equal to b1 by b2 but does not equal to c1 by c2. Okay, so since a1 by a2 is equal to 1 by 3, b1 by b2 is equal to 1 by 3 but c1 by c2 is equal to 1 by 2. Okay, so a1 by a2, this is equal to b1 by b2 but does not equal to c1 by c2. Okay, hence the given pair of linear equations has no solutions. Okay, so the given pair of linear equation has no solution. Now let us check second number. So in second, we have this pair of linear equations x is equal to 2y or y is equal to 2x, and that is x minus 2y is equal to 0 and 2x minus y is equal to 0. Okay, so here we have given this pair of linear equations, and now if we compare this pair of equation with the general form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then here a1 is equal to 1, b1 is equal to minus 2 and c1 is equal to 0. Okay, and a2 is equal to 2, b2 is equal to minus 1 and c2 is equal to 0. So therefore here the ratio a1 by a2, this is equal to 1 by 2 and b1 by b2, this is equal to minus 2 over minus 1, that is equal to 2 by 1, and c1 by c2, this is equal to 0 by 0. Okay, so here you can you can see a1 by a2, this is not equal to b1 by b2. Okay, so a1 by a2 does not equal to b1 by b2, hence the pair of linear equation has unique solution. Okay, so for this pair of linear equation has a unique solution. So this pair of linear equation has a unique solution. Now let us check third number pair of linear equations. So in third we have this pair of linear equations 3x plus y minus 3 is equal to 0 and 2x plus 2 by 3y minus 2 is equal to 0. Okay, so here if we compare this pair of linear equations with the general form of pair of linear equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then here a1 is equal to 3, b1 is equal to 1 and c1 is equal to minus 3, and a2 is equal to 2, b2 is equal to 2 by 3 and c2 is equal to minus 2. Okay, so now the ratio a1 by a2, this is equal to 3 by 2, b1 by b2, this is equal to 1 by 2 by 3, that is equal to 3 by 2, and the ratio c1 by c2 is equal to minus 3 over minus 2, and this is equal to 3 by 2. Okay, so therefore here a1 by a2, this is equal to b1 by b2. Okay, and this is also equal to c1 by c2. Okay, so therefore we get basically a1 by a2, this is equal to b1 by b2, this is equal to c1 by c2. Hence, the given pair of linear equation is consistent and having infinitely many solutions. Okay. Now let us move to question number 2. So in question number 2, it asks to us, do the following equation represent a pair of coincident lines? Okay. So here we have given some pair of linear equations, and here we have to basically check whether the following pair of linear equations are pair of coincident lines. Okay. So justify your answer. So in first one, here we have given this pair of linear equations, 3x plus 1 by 7 y is equal to 3 and 7x plus 3y is equal to 7. And in second one, we have given 2x minus 3y, this is equal to 1, and 6y plus 4x is equal to minus 2. Okay. And in third one, we have given x by 2 plus y plus 2 by 5 is equal to 0, and 4x plus 8y is equal 4x plus 8y plus 5 by 16 is equal to 0. Okay. So let us check among these which are the following equation represent a pair of coincident lines. Okay. So now let us see the answer. So here condition for coincident lines basically is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Okay. So the condition for coincident lines is a1 by a2 is equal to b1 by b2 and is equal to c1 by c2. And for first one, here we have given this pair of linear equation, 3x plus y by 7 minus 3 is equal to 0, and here we can also we have 7x plus 3y minus 7 is equal to 0. And now if we compare this pair of equation with the general form of pair of linear equation, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then here a1 is equal to 3, b1 is equal to 1 by 7 and c1 is equal to minus 3, and a2 is equal to 7, b2 is equal to 3 and c2 is equal to minus 7. Okay. So now a1 by a2 this is equal to 3 by 7, b1 by b2 is equal to 1 by 21 and c1 by c2 is equal to 3 by 7. Okay. Hence the given pair of linear equation here basically a1 by a2 does not equal to b1 by b2. Okay. So hence the given pair of linear equation has unique solution. So this pair of linear equation has unique solution. Now let us move to question number pair of linear equation number 2. So in pair of linear equation 2, here we have minus 2x minus 3y minus 1 is equal to 0 and 6y plus 4x plus 2 is equal to 0. Okay, so we have given this pair of linear equation where a1 is equal to minus 2, b1 is equal to minus 3 and c1 is equal to minus 1 and a2 is equal to 4, b2 is equal to 6 and c2 is equal to 2. Okay, now ratio a1 by a2 is equal to minus 2 by 4, that is equal to minus 1 by 2, and ratio b1 by b2 this is equal to minus 3 by 6, that is equal to minus 1 by 2, and c1 by c2 this is equal to minus 1 by 2. So therefore here a1 by a2 is equal to b1 by b2, this is equal to c1 by c2. Hence the given pair of linear equation is coincident. Okay, so this pair of linear equation is coincident. Now let us move to the third number. So in third number we have given this pair of linear equation, x by 2 plus y plus 2 by 5 is equal to 0 and 4x plus 8y plus 5 by 16 is equal to 0. Okay, so now if we compare this pair of linear equation with the general form of pair of linear equation, then here a1 is equal to 1 by 2, b1 is equal to 1 and c1 is equal to 2 by 5, and a2 is equal to 4, b2 is equal to 8 and c2 is equal to 5 by 16. So now the ratio a1 by a2 this is equal to 1 by 8 and b1 by b2 this is equal to 1 by 8 and c1 by c2 is equal to 32 by 25. That is not equal to a1 by a2 and b1 by b2. So here a1 by a2 this is equal to b1 by b2 but does not equal to c1 by c2. Okay, so hence the given pair of linear equation has no solution. Okay, so among these here this pair of linear equation minus 2x minus 3y is equal to 1 and 6y plus 4x is equal to minus 2, this pair of linear equation has a coincident solution. Okay, so has a pair of coincident lines for this pair of linear equation, and for one no given pair of linear equation. Okay, and for third one here for this pair of linear equations has no solution. Okay, so now let us move to question number 3. So in question number 3 here we have asked, are the following pair of linear equations consistent? Okay, so justify your answer. So in first one, here we have this pair of linear equations, minus 3x minus 4y is equal to 12 and 4y plus 3x is equal to 12. Okay, and in second one, here we have 3 by 5x minus y is equal to 1 by 12 and 1 by 5x minus 3y is equal to 1 by 6. And in third one, here we have 2ay plus b 2ax plus by is equal to a and 4ax plus 2by minus 2a is equal to 0, where a and b not equal to 0. And in fourth one, here we have x plus 3y is equal to 11 and 2 times 2x plus 6y is equal to 22. Okay, so now let us see the solution. So here condition for pair of linear equation are consistent, are basically a1 by a2 does not equal to b1 b2, and when this condition holds, that case we get unique solution. Okay, and when a1 by a2 this is equal to b1 by b2 but does not b1 by b2 and this is equal to c1 by c2, that case we get infinitely many solutions. Okay, so for these two cases we get at least one solution. That case this pair of linear equations are consistent. Okay, so for one, here pair of linear equations are minus 3x minus 4y is equal to 12 and 3x plus 4y is equal to 12. Okay, so here a1 is equal to minus 3, b1 is equal to 4 minus 4 and c1 is equal to minus 12, and a2 is equal to 3, b2 is equal to 4 and c2 is equal to minus 12. Okay, now a1 by a2 this is equal to minus 3 by 3, that is equal to minus 1. b1 by b2 this is equal to minus 4 upon 4, that is equal to minus 1, and c1 by c2 this is equal to minus 12 by minus 12, that is equal to 1. So since here a1 by a2 this is equal to b1 by b2 but does not equal to c1 by c2. Okay, hence the pair of linear equations has no solution. Okay, so that is this pair of linear equations is inconsistent. So this pair of linear equations are inconsistent. And now if we check second one, so in second we have this pair of linear equations 3 by 5x minus y is equal to 1 by 2 and 1 by 5x minus 3y is equal to 1 by 6. Okay, so if we compare this pair of linear equation with the general form of the pair of linear equations, then here a1 is equal to 3 by 5, b1 is equal to minus 1 and c1 is equal to minus 1 by 2. Okay, so here a2 is equal to 1 by 5, b2 is equal to minus 3 and c2 is equal to minus 1 by 6. Now the ratio a1 by a2 this is equal to 3 by 1, b1 by b2 this is equal to minus 1 upon minus 3. Okay, that is equal to 1 by 3. So since here a1 by a2 does not equal to b1 by b2, hence the given pair of linear equations has unique solutions. That is, this pair of linear equations are consistent. Okay, so this pair of linear equations are consistent. So now let us check third number. So in third one, here we have given this pair of linear equation 2ax plus by minus a is equal to 0 and 4ax plus 2by minus 2a is equal to 0. And here we have given a comma b does not equal to 0. So here a1 this is equal to 2a, b1 this is equal to b and c1 is equal to minus a, and a2 this is equal to 4a, b2 is equal to 2b and c2 is equal to minus 2a. Now a1 by a2 this is equal to 2a by 4a, that is equal to 1 by 2, and b1 by b2 this is equal to b by 2b, that is equal to 1 by 2. Okay, and c1 by c2 this is equal to minus a upon minus 2a, that is equal to 1 by 2. Since a1 by a2 this is equal to b1 by b2 this is equal to c1 by c2, hence the given pair of linear equation has infinitely many solutions, that is consistent or dependent solutions. Okay, so for third one, yes, the given pair of linear equations are consistent. Okay, and now check fourth one. So if we here we have this pair of linear equations x plus 3y is equal to 11 and 2x plus 6y is equal to 11. So here you can compare this pair of linear equation with the general form of the pair of linear equation. Then here we will get a1 is equal to 1, b1 is equal to 3 and c1 is equal to minus 11, and a2 is equal to 2, b2 is equal to 6 and c2 is equal to minus 11. Now a1 by a2 this is equal to 1 by 2, b1 by b2 this is equal to 3 by 6, that is actually equal to 1 by 2, and c1 by c2 is equal to minus 11 by minus 11, that is equal to 1. Okay, so since here a1 by a2 this is equal to b1 by b2 but does not equal to c1 by c2, hence the pair of linear equation have no solution, that is inconsistent. So among these four pair of linear equations, only second only 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 third pair of linear equations are consistent. Okay, so sorry, third pair of linear equations are consistent. Also first also second pair of linear equations is also consistent. Okay, so second pair of linear equations are also consistent. So among these four pair of linear equations, second and third are consistent pair of linear equations. Okay, now let us move to question number 4. So in question number 4, here we have for the pair of linear equations lambda x plus 3y plus 7 is equal to 0 and 2x plus 6y minus 14 is equal to 0. To have infinitely many solutions, the value of lambda should be 1. So is the statement true? So if it is true, then if you have to give reason, and if it is not true, then that case you have to also give reasons. Okay, so basically we have given this pair of linear equations, and this pair of linear equations have infinitely many solutions. Okay, and lambda should be equal to 1. So let us see how to solve it. So here the statement, we have given this pair of linear equations lambda x plus 3y plus 7 is equal to 0 and 2x plus 6y minus 14 is equal to 0. Okay, so here a1 is equal to lambda, b1 is equal to 3 and c1 is equal to 7, and a2 is equal to 2, b2 is equal to 6 and c2 is equal to minus 14. So if a1 by a2, this is equal to b1 by b2 and this is equal to c1 by c2, then system has infinitely many solutions. Okay, so it implies lambda by 2, this is equal to 3 by 6 and this is equal to minus 7 by 14, and therefore lambda by 2, that is equal to 3 by 6, and it implies lambda equal to 1. Okay, so and lambda by 2, this is equal to minus 7 by 14, and it implies lambda is equal to minus 1. So here we get distinct value, two distinct value of lambda. So hence lambda is equal to minus 1 does not have a unique solution. So for no value of lambda, the given pair of linear equation has infinitely many solutions. Okay, so the given statement for the pair of equations lambda x plus 3y plus 7 is equal to 0 and 2x plus 6y minus 14 is equal to 0 have infinitely many solutions. The value of lambda should be 1. This statement is a false statement. Okay, this is not a true statement. Okay, and now let us move to question number 5. So in question number 5, here we have to find for all real values of c. Okay, so the pair of equation this x minus 2y is equal to 8 and 5x minus 10y is equal to c have a unique solutions. So justify whether it is true or false. So we have to check for all real values of c, the pair of equation x minus 2y is equal to 8 and 5x minus 10y is equal to c have a unique solution. Okay, so let us check the statement. So the given pair of equation are x minus 2y minus 8 equal to 0 and 5x minus 10y minus c is equal to 0. So here a1 is equal to 1, b1 is equal to minus 2 and c1 is equal to minus 8, and a2 is equal to 5, b2 is equal to minus 10 and c2 is equal to minus 6. So now a1 by a2 this is equal to 1 by 5, b1 by b2 is equal to minus 2 by minus 10 and this is equal to 1 by 5, and c1 by c2 this is equal to minus 8 by minus c, that is equal to 8 by c. Okay, so a1 by a2 this is 1 by 5, c1 by c2 this is 8 by c, and b1 by b2 this is 1 by 5. So here now but if c is equal to 14, then the value of c1 by c2 becomes 1 by 5. Then the system of linear equation has an infinitely many solutions. So hence at c is equal to 40, the system of linear equation does not have a unique solution. Okay, so for c is equal to 40, and here 40, this value is basically a real number. Okay, so for at c is equal to 40, the system of linear equation does not have a unique solution. That case, the system of linear equations has an infinitely many solution. Okay, so the statement false, the given pair of linear equations, so the statement is false. Okay, so this statement is a false statement. Now let us move to question number 6. So in question number 6 here, the line represented by x equal to 7 is parallel to the x-axis and justify whether the statement is true or false. So x equal to 7, this is actually this line x equal to 7 is represented by this line that is parallel to y-axis. Okay, that is parallel to y-axis. So we observe that x equal to 7 line is parallel to y-axis and perpendicular to x-axis. So this statement, the line represented by x equal to 7 is parallel to x-axis, is a false statement. Okay, so this statement is a false statement. Now let us move to another type of questions. So here now we'll discuss short answer type questions. Okay, so here we have to find values of lambda. Do the pair of linear equation lambda x plus y is equal to lambda square and x plus lambda y is equal to 1 have number 1 no solution, number 2 infinitely many solution, number 3 a unique solution. Okay, so let us solve it. So the given pair of linear equation is lambda x plus y is equal to lambda square and x plus lambda y is equal to 1. Okay, so here a1 is equal to lambda, b1 is equal to 1 and c1 is equal to minus lambda square, and a2 is equal to 1, b2 is equal to lambda and c2 is equal to minus 1. So now for no solution, a1 by a2 this is equal to b1 by b2 but does not equal to c1 by c2. Okay, so it implies lambda by 1 is equal to 1 by lambda but does not equal to minus lambda square by minus 1. So it implies lambda by 1 this is equal to lambda square by 1 and lambda times lambda minus 1 this is equal to 0. So when lambda does not equal to 0 then lambda equal to 1. So here we take lambda equal to minus 1 because at a lambda equal to 1 the system of linear equation has infinitely many solutions. Okay, so we can take only lambda equal to minus 1 for no solution. And for infinitely many solutions, here a1 by a2 this is equal to b1 by b2 this is equal to c1 by c2, and it implies lambda by 1 this is equal to 1 by lambda, and it implies lambda times lambda minus 1 this is equal to 0, and when lambda not equal to 0 then lambda equal to 1. So for lambda equal to 1 this system of pair of linear equation has infinitely many solutions. Okay, and now third one for a unique solutions. Okay, so for a unique solution a1 by a2 this is not equal to b1 by b2. Okay, so a1 by a2 does not equal to b1 by b2, and it implies lambda by 1 does not equal to 1 by lambda, and it implies lambda square does not equal to 1, and it implies lambda does not equal to plus minus 1. Okay, and a1 by a2 does not equal to b1 by b2, it implies lambda by 1 does not equal to 1 by lambda, so it implies lambda does not equal to plus minus 1. So one real values of lambda except plus minus 1 the system of pair of linear equation has a unique solution. Okay, so for lambda equal to 1 and lambda equal to minus 1 this system of pair of linear equation has not a unique solution, but except lambda equal to 1 and lambda equal to minus 1 for all values of lambda this system of pair of linear equation has a unique solution. Okay, now let us move to next question. So in next question here we have to find the value of k for which the pair of equation kx plus 3y is equal to k minus 3 and 12x plus ky is equal to k has no solution. Okay, so let us solve it. So given pair of linear equations is kx plus 3y is equal to k minus 3. Okay, and 12x plus ky is equal to k. So now if we comparing this pair of linear equation with the general form of pair of linear equations, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, then here a1 this is equal to k, b1 is equal to 3 and c1 is equal to minus k minus 3, and a2 is equal to 12, b2 is equal to k and c2 is equal to minus k. So for no solution of the pair of linear equations, so from equation 1 and from equation 2 taking first two parts we get k by 12 is equal to minus 3 by k, and it implies k square is equal to 36 and it implies k is equal to plus minus 6. Okay, so k is equal to plus minus 6, and A1 by A2, this is equal to B1 by B2, but does not equal to C1 by C2. So K by 12, this is equal to 3 by K, does not equal to minus of K minus 3 by minus K. And taking last two terms, we get 3 by K does not equal to minus of K minus 3, minus of K minus 3 by minus K, that is K minus 3 by K. And it implies 3K does not equal to K times K minus 3, and it implies 3K minus K times K minus 3, that is not equal to 0, and it implies K times 3 minus K plus 3 does not equal to 0, and it implies K times 6 minus K does not equal to 0, and it implies K does not equal to 0 and K does not equal to 6. Okay, so hence the required value of K for which the given pair of linear equation has no solution is minus 6. Okay, so when K does not equal to 0 and K does not equal to 6, that case this system of pair of linear equation has no solution. And now let us move to question number 3. So here in question number 3, we have to find the values of A and B for which the following pair of linear equation has infinitely many solutions. Okay, so we have this pair of linear equation x plus 2y is equal to 1, and a minus b times x plus a plus by is equal to a plus b minus 2. Okay, so let us solve it. So here we have pair of linear equations are x plus 2y is equal to 1, and a minus b times x plus a plus b times y is equal to a plus b minus 2. Okay, and when comparing the pair of linear equations, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, here a1 is equal to 1, b1 is equal to 2 and c1 is equal to minus 1, and a2 is equal to a minus b, b2 is equal to a plus b, and c2 is equal to minus a plus b minus 2. Okay, so now for infinitely many solution of the pair of linear equations, a1 by a2, this is equal to b1 by b2, and this is equal to c1 by c2, and it implies 1 by a minus b, this is equal to 2 by a plus b, and this is equal to minus 1 by minus of a plus b minus 2. Okay, and taking first two terms, taking first two parts, 1 by a minus b, this is equal to 2 by a plus b, and it implies a plus b, this is equal to 2a minus 2b, and it implies 2a minus a, this is equal to 2b plus b, and it implies a is equal to 3b, and naming this equation number 3. And now 1 by a minus b, this is equal to 2 by a plus b, and if we simplify it, then we will get a is equal to 3b, and taking the last two terms, two parts, then we get 2 by a plus b, this is equal to 1 by a plus b minus 2, and this implies 2a plus 2b minus 4, this is equal to a plus 4, a plus b, and it implies a plus b, this is equal to 4, and naming this equation number 4. Okay, now put the value of now if we solve this two pair of linear equation by putting the value of y is equal to 3b in equation number 4. Okay, then we get 3b plus b is equal to 4, and it implies 4b is equal to 4, and it implies b is equal to 1. So put the value of b is equal to 1 in equation number 3, then we get the value of a is equal to 3. So the values of a comma b is equal to 3 comma 1 satisfy all the parts, hence the required values of a and b are 3 and 1 respectively, for which the given pair of linear equation has infinitely many solutions. Okay, now let us move to question number 4. So here we have to find the value of p in 1 to 4 and p and q in 5 for the following pair of linear equations. So 1 to 4, here we have to find the values of p. Okay, and for the fifth we have to find the value of p and q. So let us solve it. So for a given pair of linear equations is 3x minus y minus 5 is equal to 0 and 6x minus 2y minus b is equal to 0. And when comparing with the general form of the pair of linear equations, then we here a1 is equal to 3, b1 is equal to minus 1, and c1 is equal to minus 5, a2 is equal to 6, b2 is equal to minus 2, and c2 is equal to minus p. Okay, and since the lines represented by this equation are parallel, then a1 by a2, this is equal to b1 by b2, but does not equal to c1 by c2. So it implies 3 by 6 is equal to minus 1 by minus 2, and this does not equal to minus 5 by minus p. And now taking the last two parts, then we get minus 1 by minus 2, that is equal to minus 5 by minus p, and it implies 1 by 2 does not equal to 5 by p, and it implies 5p does not equal to 10. Hence the given of pair of linear equations are parallel if all real values of p except 10. That is P belongs in R minus 10. And for second, here given pair of linear equation is minus x plus py minus 1 is equal to 0 and px minus y minus 1 is equal to 0. So when comparing with the general form of the pair of linear equations, here a1 is equal to minus 1, b1 is equal to p, and c1 is equal to minus 1. a2 is equal to p, b2 is equal to minus 1, and c2 is equal to minus 1. Since the pair of linear equation has no solution, that is both lines are parallel to each other, then therefore a1 by a2 this is equal to b1 by b2 but does not equal to c1 by c2. And it implies minus 1 by p, this is equal to p by minus 1, and this does not equal to minus 1 by minus 1. And now taking the last two terms, we get p of p by minus 1, this does not equal to minus 1 by minus 1, and it implies p does not equal to minus 1. And taking the first two parts, we get minus 1 by p, this is equal to p by minus 1, and it implies p square is equal to 1, and it implies p does not equal, p is equal to plus minus 1. Okay, but does not equal to minus 1, so therefore p is equal to 1. Hence, the given pair of linear equation has no solutions for p is equal to 1. So for p is equal to 1, this pair of linear equation has no solution. And now let us move to third one. So in third one, here we given pair of linear equation is minus 3x plus 5y minus 7 is equal to 0. This is 1, and 2px minus 3y minus 1 is equal to 0. This is 2. And on comparing the pair of linear equation, we get a1 is minus 3, b1 is 5, and c1 is equal to minus 7. a2 is 2p, b2 is minus 3, and c2 is equal to minus 1. Okay, and since the lines are intersecting at a unique point, that is it has a unique solution, that is a1 by a2 does not equal to b1 by b2, and this implies minus 3 by 2p does not equal to 5 by minus 3, and it implies 9 does not equal to 10p, and it implies p does not equal to 9 by 10. Okay, hence the lines represented by this equation are intersecting at a unique point for all real values of p except 9 by 10. So similarly you can do fourth one. Okay, and you can also do fifth one. So in fifth one, we have to find the values of p and q. Okay, so we have given this pair of linear equation, and when comparing, we get a1, the values of a1, b1, c1, and a2, b2, c2. And since the pair of linear equation has infinitely many solutions, that is both lines are coincident, that is a1 by a2 this is equal to b1 by b2, this is equal to c1 by c2, and it implies 2 by 2p, this is equal to 3 by p plus q, this is equal to minus 7 by minus 28. Now taking first and third first, then we will get 2 by 2p, this is equal to minus 7 by minus 28, and it implies p is equal to 4. And again taking the last two terms, then we get 3 by p plus q, this is equal to minus 7 by 2 minus 28, that implies 3 by p plus q is equal to 1 by 4, and it implies p plus q is equal to 12, and it implies 4 plus q is equal to 12, and it implies q is equal to 8. Okay, so here we see that the values of p is equal to 4 and q is equal to 8 satisfy all three parts. Okay, hence the pair of equation has infinitely many solutions for the values of p is equal to 4 and q is equal to 8. So student, here I stop this lecture. Thank you very much to all of you.